You press a lever, there's a swirl, a roar, and one of life's least photogenic moments disappears. And then society politely agrees never to ask where it went. We call this flushing. But really, your toilet is a portal to a secret underground bureaucracy. The moment the water leaves the bowl, your private bathroom connects to one of the most important public health systems humans have ever built. Because a way is not a magical kingdom. A way has pipes, pumps, tanks, microbes, and employees with very specific jobs. First, the missing evidence drops through the toilet's trapway, that curved bit of plumbing holding water, which helps block sewer gases from wandering back into your bathroom like unwanted ghosts. From there, it enters your home's drain pipe, then usually a private sewer lateral, and then the larger sewer main under the street. And now your flush is no longer alone. It joins shower water, laundry water, sink water, food scraps, toilet paper, soap, grease, grit, and mysterious household liquids that probably deserve a trial. The sewer is not just poop pipes, it is the city's least glamorous subway system. A lot of the ride is powered by gravity. Engineers design sewer pipes to slope gently downhill, so wastewater keeps moving without needing a motor every 5 feet. But cities are not perfect slides. Sometimes the land is too flat, or the pipe gets too deep. That's when pump stations step in. Basically, elevators for things no elevator wants to carry. Before the wastewater reaches the treatment plant, the underground world has enemies. Tree roots sneak into cracked pipes. Grease cools and hardens. Wipes, even some labeled flushable, can survive the toilet and then team up with fat to form sewer monsters called fatbergs. So, quick public service announcement. The sewer is not a trash can with better plumbing. Wipes, toys, phones, and anything that looks like treasure from a cursed pirate chest should not be flushed. Eventually, the flow arrives at the wastewater treatment plant, the answer chamber of our mystery. And the first thing the plant does is not exactly clean the water. It protects itself. Large screens catch rags, wipes, plastic, and other debris before they can wreck machinery. Then grit chambers slow the flow so heavy stuff like sand, coffee grounds, and eggshell bits can settle out. Next come settling tanks, also called primary clarifiers. Here, heavier solids sink to the bottom as sludge, while oils and floating material rise to the top and get skimmed away. At this point, the water may look less chaotic, but it still contains dissolved organic matter, tiny leftovers too small for screens and settling tanks. So the plant calls in the smallest workers in town, microbes. In biological treatment, bacteria and other microorganisms eat or break down much of that organic pollution. They are tiny unpaid treatment plant workers doing the dirtiest job in civilization. After that, the water usually goes through more clarification and then disinfection, often using chlorine, ultraviolet light, ozone, or other methods to reduce harmful microbes before the treated water returns to a river, lake, ocean, or in some places, a reuse system. Important detail: treated wastewater is not automatically drinking water. Turning it into drinking water requires extra treatment, testing, and local approval. But the ordinary plant is already doing something astonishing, taking a dangerous urban mixture and making it far safer for the environment. And what about the solids? The sludge has its own afterlife. Depending on the plant and local rules, it may be digested by microbes, dewatered, sent to a landfill, incinerated, or treated into regulated biosolids. Some facilities use anaerobic digestion to produce methane-rich biogas, turning part of the problem into energy, which is weirdly poetic. The thing you wanted gone becomes electricity, heat, cleaner water, or a carefully managed byproduct. This hidden system matters because, for most of history, cities were terrifyingly bad at separating waste from water. Crowded streets, cesspits, open drains, polluted rivers, all of it could feed diseases like cholera and typhoid. In 1854, John Snow's investigation around London's Broad Street pump helped show cholera was spreading through contaminated water. A few years later, the Great Sting of 1858 helped push London toward massive sewer reforms. Sewers alone did not save everyone. Clean drinking water, filtration, chlorination, plumbing codes, public health departments, and treatment plants all mattered. But together, they made dense modern cities possible. Millions of people can live close together because we do not have to drink each other's sewage. So the next time you flush and instantly forget, remember that tiny private moment has just entered a public health machine made of gravity, concrete, steel, biology, chemistry, and people working jobs most of us never see. A flush is not an ending, it is a handoff, and civilization depends on what happens after. If this changed how you see your bathroom, subscribe because the ordinary world is usually hiding the strangest machinery.